All right there, class. We're here today to look at Ohm's law and an example problem that deals with that. So by the end of this video, you should have an idea of what Ohm's law is and be able to actually solve problems with that. So here we are. We have some kind of circuit. Our circuit here has a battery in it, and that battery has a voltage of 1.5 volts. And the current goes around our circuit. And this is electron current, by the way. But the resistance here, the resistor that it goes through, is 500 ohms. So our goal is to find out what kind of current we actually have in our circuit. So let's start off by writing down Ohm's law. Ohm's law is the voltage equals current times resistance. Now our goal here is to find the current, which is the letter I. So what we're going to need to do is get this R, the resistance, we're going to need to get it to the other side of the equation. Now I always ask myself when I'm doing this, what is the I doing to the R? What are these two things doing? Well, in this case, I times R. So I always want to do the opposite to get rid of it. So what I'm going to do is I'm going to divide by R. Now that actually cancels out R on the side, leaving us with just the I, which is exactly what we want. Now remember, when we do algebra, we always have to do it to both sides to keep it algebraically equivalent. So when I do that, I'm going to get V divided by R over here on the left-hand side, and I'm going to get I on the right-hand side. So basically what this comes down to is that I, which is current, is going to equal V divided by R. So I'm going to need to take my voltage, which is right here, the 1.5 volts, and I'm going to put it in here for V. I'm going to take my 500 ohms, and I'm going to put it in here for R. So making the substitution, 1.5 volts for V and 500 ohms for current. This is going to give me 0.003 volts per ohm. Now, as we've learned, a volt per ohm is really like saying ampere, which is abbreviated with an A. Now, something that most people probably would do here, we don't generally talk about such small amperage or current here. Typically, we'd want to convert this into something that's more usable. So in this case, I would convert this into milliamps, and keeping in mind that there's 1,000 milliamps in every amp, basically we're going to something that's 1,000 times smaller than the amp, so our number has to get 1,000 times bigger. So what I end up with is I equals 3 milliamps. Now again, the first answer I have here is perfectly acceptable too, but typically we express this in something that is a smaller unit.